Okay, see, we will start this geography current affairs, ma. You see, look at here. There is a news on this. What does this mean? World Environmental Day of 2023. So, what they proposed is waste dumping is polluting the Jhelum River in Kashmir with microplastics. So this is actually the news which we saw in that newspapers. When you're looking to this, you see this. The theme of that World Environmental Day 2023 is beating the plastic pollution, and the entire world is deliberating ways of dealing with plastic pollutions. So if you see that in the water bodies, wherever if you go, in the ocean or the sea whatsoever, not only there, in the rivers and as well as the lakes, there we can find lot and lot of microplastics and nanoplastics. And usually there is a current news which we will read it, that this microplastics which is most used in that facial, you know, that facial cream that you are using, no, from there that we are using more number of microplastics. So whatever that we are using in that for facials and all, it just be in that rivers, and that from the rivers it went to the ocean and the sea. So this is the thing. But recently, as an example, the scientists which they were finding that there is a river which is called as Jhelum River in Kashmir. It got to be completely polluted because of this microplastics. So this is the news that we had in that newspaper. Let's see this. So what are the right bank tributaries of Jhelum and left bank tributaries of that Jhelum? You see, from that Srinagar, it's originate in that Srinagar, and that Jhelum River goes with the Pakistan, and it joins with Chenab. This Chenab, which is also from India, but we studied that what are the tributaries of Indus. Actually, Jhelum, which is the tributary of Indus, but Jhelum has its own some tributary. You see, if a river is flowing like this, if a river comes and joins, some rivers are joined with that river. These rivers are called as tributaries, right? So we have that right bank and left bank tributary. All we read it in that our and these are the right bank tributaries, whichever they're here, that they are called as the right bank tributaries of Jhelum, and also these are called as the left bank tributaries of that Jhelum, and also the Jhelum is one of the tributary of Indus. It's finally in Pakistan, it joins with that Indus. So Jhelum is a tributary of Indus, but Jhelum has its own tributary, lot of tributaries which are there. We might have get a question, because in the current affairs, what they will did it mean? You see, this current affairs, we got a simple news that scientists finding that some of the microplastics in Jhelum River, right? They might have asked you something about in microplastics or about the Jhelum River. But in geography, when we are move away from that microplastic, it comes under the environmental studies. But when we are reading with the Jhelum River, we will have to go with the geography, right? So if you see on this, the next one, you see, there is a lake on that Kashmir, the lake which is called as Achan Lake or Ankar Lake, both are the same. But you see this, until 1983, this Ankar Lake, which is a wetland ecosystem, that is the second largest lake in Kashmir. In Kashmir, we have lot of lakes. Dal Lake is there. Ular Lake, which is also there. We studied in that all these things in conventional area, But until 1983, it's not right now. Until 1983, this Achan and Ankar Lake, which is the second largest lake. But recently, what happened means there is lot of land fillings which happen on that wetland and waste are dumping on that site. So they might have asked you, where is this Achar Lake? Anchar Lake or Achan Lake, which is in Srinagar, that's in the Kashmir. So if you see that, what does this actual mean? This Ankar Lake, which is connected with the Dal Lake which is also in Srinagar, both are to be connected. It is connecting via a channel, that channel which is called as Amir Khan Nalla channel. They might have asked you these questions. So this have highly polluted, and also this Dal Lake which is also to be highly polluted over on here. So these are the newses that we are having in that newspapers. Now if you see that next you see this, the Dal Lake, I told you, no, which is also in Jammu and Kashmir. Wular Lake, which is also in Jammu and Kashmir, but there is a community. That community is called as Hanji community, which they are living near that lake, that they are called as Hanji community. So these are the local peoples over there in that places. So by the way, from this news, we got it that what is the theme of that World Environmental Day, one thing, and which river is completely got to be polluted by the microplastics, that is called as Jhelum River. On the last video we studied about how Yamuna River is got to be polluted. So, and we studied that the Jhelum River has some right bank tributaries and also the left bank tributaries, and even though what are the lakes which are over there in that Srinagar, that is in the Jammu and Kashmir, one is Dal and other one is Wular, and which community which is over there in that region, means nearby this region, they are called as Hanji community, right? So fine, the next where is this? Yes. Okay. Yes. You see this news, ma? Actually, there is a tree in North India, not only in North India, in somewhere in the part of India. That tree which is called as Mahua. The tribal peoples who are living there in that Odisha, they are making some laddus from this Mahua tree. This is actually the news. Look at here. You see this. This is the scientific name of that Mahua tree, but where it is, really it's where it in India. Central India, Southern India, North Indian plain and the forest of Nepal, Myanmar, Sri Lanka. So these are the places which we can find this Mahua tree. It's a tree, right? Central, southern means even though we can see that Mahua tree in Tamil Nadu also. In Tamil Nadu it has different names. You see, look at here. You see this. This is a common names which for that Mahua tree. You see, you know that Iluppai, which is in Tamil Nadu. So when we are seeing these parts, that is in central India, southern India, northern Indian plains, and as well as in the forest. So we might have know that where it is mean. You see, in central India it is there, southern India which is also there, and also in the northern plain region of here, Uttar Pradesh, Bihar and all, you can find these kind of trees. But this tree is not in Himalayan mountains and northeastern states, right? So this is the news that we get it from this Mahua tree. From here we have lot of different names over there, and also we will have something about this Mahua tree. You see this, actually This mahua tree, which is a fast growing tree, and it has the height of 20 meters. Look at here. When a tree is growing 50 to 60-meter height, that is above 40 meter or 50 meter or 60 meters, it's supposed to be only in the evergreen forest, right? But this tree which is growing only 20 meter in high, that's why I said this is the deciduous trees. This in the deciduous forest and all, we can find these kind of mahua tree, not in the evergreen forest. You see, if I'm drawing this India, you can find mostly the deciduous forest over on here. You can also find some evergreen forest, that is big leaves. It just be there some 50 to 60 feet height and all. We can find out some trees that they are called as evergreen trees, evergreen forest, tropical evergreen forest. So this tropical evergreen forest confined exclusive only to this area, where mean the west side of Western Ghats, and also in some part of this Himalayan mountain and all, that is especially in the northeastern states and all, we can find these kind of tropical evergreen forests. But besides this, most of India we will have that deciduous forest, that in that deciduous forest we will find these kind of mahua tree, and you know that it can be adaptable to the arid environment. If you have no that much of rainfall, yes, it can sustain it, but the evergreen trees are not. It needs that much of rainfall, that is more than 200 centimeter of rainfall. This might be adaptable for this arid environment. That's why this forest, which is called as deciduous forest, you see that state Odisha, Chhattisgarh, Jharkhand, Uttar Pradesh, Bihar, Maharashtra. So these are the places that we can find these kind of trees. And also in Andhra Pradesh, I told you that in the southern states, and Madhya Pradesh, and also in Kerala, Tamil Nadu, Gujarat, West Bengal, all over. But can you find any Himalayan mountain region of Jammu and Kashmir? It's not there. Uttarakhand, which is not there, and Himachal Pradesh is not there. Even though northeastern state, any of the northeastern state is not on here. So that's why I told when I'm drawing this India, this mahua tree, which is not over there on here, but all over other states, we can find these kind of trees, right? So if you see this, so what they are preparing, the tribal peoples who are living there in Odisha, they are collecting the mahua flowers during some particular season. You know that during the spring season, that is in the month of March, blossoming season, that is the flowering season, that is called as the spring season, in the month of March. During that time, these peoples are collecting the mahua flowers, and the tribal peoples who are preparing some of the items like this, laddus, cakes, jam, toffee and all, etc. and etc. So from that dry mahua flowers, fine, okay, you see this, yes, you see the mahua flowers, which are mainly used for brewing local liquors, are popular across India. This is true. Some kind of alcoholic substances which are present there in that mahua flower, it's a tree, right? So from that mahua flower, they are making some liquors. That is the common thing which we are making in that across of this India. But the tribal peoples who are living there in Odisha, especially in Kandhamal district, this is the livelihood source that they are making laddu, jam, cakes, etc., etc., toffees and all. So this is a delicious varieties of foods they are making over there. You see this. This mahua laddu is high demand compared to the other products, definitely. When you go and see this Odisha in that tribal area, this is very highly demanded, and they are some of the ingredients just like cashew nut, groundnut, jaggery, that they are making it. I told you, no, the tribal peoples who are living there, they are collecting that mahua flower only between February and April, because March the spring season starts. So February March and April, these are the spring season. That is, the starting season is February, peak season is March, but the ending season is April. So these 3 months, these peoples are collecting moreover that mahua flower and making of these delicious items. Fine. You see this, but you have to know that what is the exact content of that flower. You see this, the flower contains 40 to 50 percentage of sugar, and it has also protein which has 5.62%, and also this flower is rich in fiber, rich in calcium, rich in phosphorus, and also this is rich in vitamin C. We might have get a questions like this about the flowers. Okay, so the tribal peoples, not only the tribal peoples of Odisha, you see this, the states like Madhya Pradesh, Chhattisgarh, Jharkhand, Gujarat, Maharashtra, they have also prepared some several products which are over there in their state, but especially this Mahua Laddu, which is very, very famous there in Odisha, that is making up by the tribal peoples who are living there. So this is the contents that we are collecting from these kind of newses. Then the next one, you see this as an important thing, before joy. What does this mean? You see, actually this is a depression which forms over in the Arabian Sea. That depression might have converted into a cyclone, right? Look at here. Now you might have asked me a question. What is, sir? What is depression and what is called as the cyclone and all that we studied in that our conventional area, Look at here. The depression, first depression is formed in that Arabian Sea. You see, southeast of this sea, and it has the wind speed which up to 45 to 55 kilometer per hour, that gusting to 65 kilometer per hour. So what is the real logic that we are thinking here means, when a depression, when the wind speed, that is the velocity of the wind, which might have increasing, that is called a cyclone. You got the difference? Depression. First the depression might have got in that sea, then after that it might have converted into the cyclone. That's the wind speed, when it's getting more, that it might have converted to cyclone. You see, look at here. I will show you that this is depression. This is cyclone. You see this? This might have the wind speed up to 45 kilometer per hour. But when the wind speed might have 100 kilometer, 120, 80 kilometer per hour, 85, 90, 100, 120 kilometer, it might have converted into the cyclone. So this is the difference. We study, we will read that all the things in conventional. Now look at here. Let's see this. You see, when a cyclone forms, the depression, now when converted into the cyclone, they suggested one name, that name which is called as Biporjoy, right? Actually, this name is suggested by a country that is called as Bangladesh. So we have some 11 to 12 countries. They are suggesting some cyclonic names, periodic tables also. If a cyclone comes, this name which is for this cyclone, this name which is for from this country. So each and every country that they are contributing their own names for that cyclone. So today one cyclone is happening there, Bangladesh name Biporjoy will be there. Tomorrow if a cyclone will be there, Indian name which over there. So these are the things. So you see this, an exceptional warm Arabian Sea, a weak monsoon of onset. This is true. What does it mean? What is the real logic is, whenever if a cyclone is a strong cyclone, okay, you see this, when I am drawing this India, if this is Arabian Sea, right? When a cyclone which is more stronger on here, all the moisture content may move on this cyclone like this. So there is an absence of moisture content in the mainland, so we don't get that much of monsoonal wind. right? So what is the real logic we have to find it? Mean when the Arabian Sea get more warmer, cyclone might have strong. So for that, the monsoon rainfall may weak or delayed in India, right? So if you see this, there is a favorable Madden-Julian oscillation which is there. That condition is favoring to this cyclone. So we have to read about what is called as Madden-Julian oscillation. Look at here, ma. You see this, when I'm drawing this, this is Australia, India, and North America, South America. This is called as Pacific Ocean. What does this Madden-Julian oscillation mean? Look at here. In Arabian Sea, this Madden-Julian oscillation which is prominent in Indian Ocean or in the Pacific Ocean and Pacific Ocean. Look at here. When the air mass rises over on here, cloud formation will be there, so rainfall comes. So what happened when the rising of this air mass will move to the east and subside in the Pacific Ocean? When the air mass subside, there is no cloud formation, so that's why you have a dry weather which might be possible in the Pacific Ocean. So now look at here. When this is called as Madden-Julian oscillation. This is the phenomena which occur every 30 to 40 days, 20 days, 30 days or 40 days, it might have occurred. But in the reverse system, if the air mass in Madden-Julian oscillation, if the air mass rises in Pacific Ocean, now what happened? Cloud might have happened on here, so the rainfall comes over on here. But when these air mass subside in the Arabian Sea, that is in the Indian Ocean, that in India we don't have that. So there is a positive and as well as negative features are there. So this Madden-Julian oscillation is right now in that cyclone which happens in Arabian Sea. So it strongs the cyclone more, but it delays the monsoon rainfall. Okay, wow. Now look at here. You see this, the Madden-Julian oscillation, which is the oceanic atmospheric phenomena. That's why I told the air mass rises to the atmosphere and it got to be subside over there, and it affects weather activity across the globes. Look at the major fluctuation in tropical weather on weekly or monthly time scale. Yet, yes, I told that Madden-Julian oscillation might be of 20 days or 30 days and after. So every 20 to 30 days we have the weather deflections which are there. Now you see this, I told that it pushes this eastward moving pulse of that cloud. It's not pushed to the westward, it always pushes to the eastwards. So now what happened means the rainfall, wind, pressure that in the near to the equator typically occurs every 30 to 60 days. It might have happened. It pushes only to the eastwards, right? Now look at here. You see this. It is a traversing phenomena. What is called this traversing phenomena mean? From Indian Ocean to Pacific Ocean, from Pacific Ocean to Indian Ocean. This is the traverse phenomena and is most prominent over Indian Ocean and as well as the Pacific Ocean. You see this, when it is over the Indian Ocean during the monsoon season, it brings good rainfall over the Indian subcontinent. So what is the real logic is, whenever Madden-Julian oscillation which is in Indian Ocean, it favor to our monsoon, that we will get more amount of rainfall. But if that Madden-Julian oscillation which is in Pacific Ocean, there is a weak and monsoon. But right now what it is happening mean, the Madden-Julian oscillation is there, but cyclone forms no. So moisture will go to the sea. There is no that much of rainfall in the mainland of India. We have that kind of moisture content in the cyclone, but that cyclone landforms only in Pakistan and Oman. Whatever the rainfall which is coming to India, it just be sucked by that cyclone, and that cyclone which is traveling to Oman. So there is a delay and there is a break in that monsoon on this time. That's why on this year 2023, the southwest monsoon, we will have a weak or delayed southwest monsoon. If you see that pattern in that satellite and all, let's see that we have a slight cloud in that India right now. This is 6th of this June now. We have a very slight cloud. Okay, so this is the one thing. So what are the two things we have to know means, Madden-Julian oscillation is favoring if it is in Indian Ocean, but if it is in Pacific Ocean, we have that much of not unfavor to India. So the next one, if you see this, I told that I finished it. Okay, you see this. The sea surface temperature are 30 to 32 degrees Celsius. Yes, when the sea temperature which is very high, air mass rises up. So that's why you have that 30 to 32 degree of that Celsius, and high sea surface temperature favor for the formation of that cyclone. Yes, obviously we have that cyclonic formation. Look at one more thing. There is a difference between El Nino, that is called as ENSO, El Nino Southern Oscillation, and this Madden-Julian oscillation. Look at here, El Nino, which is a ocean current, that is a local ocean current. This is a warm ocean current in the Pacific Ocean near to the Peruvian coast. But this Madden-Julian oscillation, which is the phenomena of sea and the atmospheric weather. This is the difference of these kind of El Nino and Madden-Julian oscillation. You see this? So the system, what the system means? The cyclone will delay the arrival of the southwest monsoon. The system, that is the cyclone, is driving moisture away from India and is hindering monsoon winds. This could be a further cause of delay in the onset and progress of monsoon. So this is the problem that we have right now when the Biparjoy cyclone, which creates in that Arabian Sea. So look at here, when a cyclone is strong, monsoon is weak. When a monsoon is strong, cyclone is a weak. Rendume at a time la varadu. We don't have these two in the same time. But the Madden-Julian is favor for cyclone, monsoon will delay. If the Madden-Julian is favor for that monsoon, cyclone will delay. This is the logic, right? So next you see this. I told you no. The system intensify depression in 8:30 a.m. but a deep depression in 11:30 a.m. but a cyclone which creates in 5:30 p.m. in the same day. Actually, what it says means, inside that ocean and all, in a single day, when a depression has happened, suddenly it might have converted into the cyclone. It don't take that much of time. Maybe in some times, if a depression is on today, cyclone might have 1 week after, or may cyclone dies in that sea itself. Right? So this is the logic we can find over on here. You see that Biparjoy wind speed is 115 to 125 kilometer and a gust of 140 kilometer per hour. So depression means the wind speed is very low. Then deep depression means the wind speed is getting high. But if it is a very strong, then it converted into the cyclone. So that is the thing. And one more thing you should know it, there is a software which created by European Center of Medium Range Weather Forecast. The software name is called as Windy. This Windy, which visualize these kind of cyclones, there's a special software which created by the European Center for Medium Range Weather Forecast. It's a model of that software that is called as Windy. Windy, Windy, right? Next, if you see this, in Pakistan, if you see, I told that this Biparjoy cyclone landfalls in Oman, but we have that much of rainfall in Pakistan because it's crossed Pakistan. Look at here, the cyclone storms of 1895 up to on this year, up to 2 in 2007 and 2010. So Pakistan have that much of cyclonic influence which there in that country. This Windy software, what it has done means, it visualized that the cyclone which has landfall in Oman, that is the country, You know that there we have tropical cyclone and temperate cyclone. Tropical cyclone hits always western side of the continent. Temperate cyclone hits always eastern side of the continent. Sorry, tropical cyclone which hits always eastern side of the continent. Temperate cyclone which hits western side of the continent. So we have that Oman and all, right? So this moving in north and northwest direction. It's not moved to northeast. It is moving to north or northwest direction of that country. That's why from this Arabian Sea, if you are seeing this, from this Arabian Sea, this is moving on northwest like this. So that we have that Oman country which got to be affected, and it is a tropical cyclone. It's not a temperate cyclone. We have the two difference. So its landfalls in that Oman. Now, if you see that the system cyclone will delay the arrival of the southwest monsoon. The system is driving moisture away from that India and is hindering monsoon wind. That's why I told whatever the moisture which are over there in that mainland of India, it is obviously sucked by that cyclone and all. So it causes might be further delayed the onset of that monsoon. So you see this. The long-term Indian Ocean warming and the developing of El Nino both have the potential to weaken the monsoon. I told no. When El Nino effect which is there in the Pacific Ocean, it weakens the monsoon. One thing. Then the second thing, Madam Julian oscillation which favor for the stronger of that cyclone, so it also weaken the monsoon. That's why this year, this both El Nino and Madam Julian oscillation, we have the problem in that monsoon. So that is the problem we have it. Now, yes, you see this. If a cyclone is moving away from the mainland, when it is coming to the mainland, we have the rainfall. But now the cyclone is moving away from the mainland, it is driving the moisture away. So it is going to Oman, not coming to India. So it's driving all the moistures away. So the onset of southwest monsoon, which typically lasts from June to September, has been delayed of this year. Definitely we will have the delay. So it typically sets in Kerala in the month of June 1st. Whenever the June 1st comes, we will have that monsoon, and the entire country it will cover around of July 15th. So during this particular cyclone, monsoon onset might be delayed and weak because of Madam Julian oscillation and as well as El Nino effects. Then westerly wind which pulls the monsoon towards the Indian mainland are weak now. All the moisture is rotating around the cyclone. I told you no. There is one thing that we studied in that on India. This westerlies which blows like this. This is westerlies. When westerlies blowing like this, so monsoon will hit on here to the mainland of India. But unfortunately, what it is happening, this westerlies is weak right now. That's why cyclone which is moving on that side. Right? So rainfall will be weak over peninsular India and several part of such situation where in India, if you see, these are the years that we have these kind of very weak cyclone, because the very weak monsoon, that because of the cyclone and as well as the Madam Julian oscillations. And if you are seeing the next one, you see this. About 70% of tropical cyclone and 90% of very severe and super cyclones over the Arabian Sea strike during the May, June and November, according to the paper study of 2021, which is the exactly a transition period when comes the cyclone which is forming over there in that all over the world. So this is the exact May, June and the November we will have it. Super cyclone means when it speed which is up to 180 kilometers, that is called a super cyclone. Depression, deep depression, cyclone, super cyclone, when the speed, because of the speed we have these kind of different names. Then how the cyclone and monsoon that are to be interacting. You see this, cyclone cannot form if we have a strong monsoon. Yes, I told you no. When this is strong, this is weak. When this is strong, that one is weak. A weak onset of monsoon result in the formation of a cyclone. You might have get these kind of questions. When this is weak, this must be strong. When this is weak, then this must be strong. So you have these kind of differences. And if the southwest monsoon current is strong, winds blows in two directions. southwest in lower level and northeast in the upper level, right? This prevent the cyclone from rising the vertical, hindering it. You see this. The cyclone will rises its air in a vertical position like this, right? Look at here, when the cyclone is rising up like this, it's a vertical way. When a strong monsoon wind is coming, so cyclone never ever forms. When this monsoon wind is very weak, definitely the cyclone will be very strong. So this is the reason we have it. Then look at here, this time the monsoon is weak, allowing the cyclone to develop vertical as it can pass through the winds and move upward. Yes, obviously the reason, the onset is not clear, but it could be El Nino, the warm phase of the recurring climate pattern across the tropical Pacific. Indian Ocean warming due to the climate change could also be playing on the role. Yes, that's it. Because of Madden-Julian oscillation and because of Indian Ocean is warming and because of this El Nino. These are the three things. So they might have give you like this A, B, C, which one is correct and which one is wrong. So you should be clear about of all these things. And the moving away from mainland, it is driving moisture away. But if it is progressive towards the coast, it could enhance the monsoon. If it is coming over on the mainland, definitely we will have a good monsoon. But cyclone is strong, but it is moving away and it is getting all the moisture and it is driving out to Oman. So that is the greatest problem over there. For instance, cyclone Nisarga, this is the previous cyclone that helped the progressive of the monsoon since it moved towards the subcontinent along with the monsoon, right? So this Nisarga, which moves towards the mainland, but Biporjoy is moves towards the away from the mainland. So that this favor for that monsoon, but that Biporjoy is not favor for that our monsoon. So that is the thing. And such El Nino can influence its progress. If La Nino prevents means, yes, definitely we will have that much of good rainfall. But right now, before that ending of 2023, the La Nino stops, El Nino started. So we have that these kind of problems. You see, this cyclone Biporjoy is the second most intense rapid intensification by a North Indian Ocean cyclone that formed in June. It holds the second position jointly with cyclone Vayu. Actually, Vayu is the most rapid intensified cyclone. The second cyclone that we have right now is Biporjoy. So recent past we are seeing cyclones rapidly intensify due to the warm ocean condition. This tends as emerged in the last decades or so. So if we have a very warm oceanic influence, that the cyclone will be very, very strong. So this is the basic things we have to know about of this. Yes, so that's all about this current affairs, ma. So we will see on the next class. Thank you. So I think